Hello everyone, my name is Umesh. Today I would like to discuss about concurrency in Go. So I made a video about concurrency in Rust with async await like a couple of days back. So then I thought, why can't we make a concurrency in Go? So here I am. Let's get started. So before we go into anything, the concurrency in Go will be can be achieved using Go routines. So today we're gonna discuss about Go routines. So I made a list. We'll learn about all these things, and we'll also learn about buffer channels in upcoming video. So in this video, I'm going to cover all these topics. I hope you like it, and let's get started. So I have written like a small example. So let's this code. Let's run this code. Go run .go. You can see it printed main. So let's start with a simple function which says say hello, and I'm going to write println says hello. So once we'll call this function from a main, and let's run. So now you can see it prints both hello and main. So the concurrency in Go achieved by Go routines. So how do we write Go routines? It's fairly simple. We have this function called say hello. So if I want to run this say hello function in another Go routine, we can achieve that by writing Go keyword in front of that function. So now what happens? Every Go program runs. This main function runs on main Go routine, and now we are kicking off a new Go routine to run this function. So each Go routine is going to have its own stack. That means say hello and this main function runs on two completely different stacks. So let's run and see how it goes. Now you can see before that we have seen both hello and main. Now we can see only main. The reason being is that as we already discussed, say hello function runs on its own Go routine and its own stack. Now main Go routine runs on its own stack, and the main doesn't know that whether that say hello function Go routine has finished yet or not. So main Go routine is not going to wait for that say hello function. Once the main function stack is done, it's going to exit the program. So to avoid this, let's say I'm going to write time.sleep and wait for a second. Now what we are trying to do here, so I'm going to call this function and run this function in a main different Go routine. I'm going to wait for 1 second, and then we'll print main. Let's run. So we have hello, and we are waiting for a second, then we are printing main. So now you can probably understand, right? So Go routine runs on its own stack, so main Go routine is not aware that say hello Go routine has been finished or not. Both are completely different, running differently, right? So this is not the solution. In real time, you cannot really say whether it's going to take a second or 2 seconds or 3 seconds. And that's not the solution. So let's remove that, and let's keep this function as it is. First, we'll come back to this function a little bit after, and then we'll start. Now we'll write some examples. So let's say you have a function which, let's say, connect DB, which connects to DB and returns the DB client. So in real time, it's probably going to return the DB client. Since we don't have the DB client in real time to show, I'm going to return string. Then I'm going to write like fmt dot sprint f return, not needed. I'm going to write simple like return DB connected. Okay. In the same way, let's have one more function to connect the redis. I'm going to say connect redis. Then it also returns a string. In real time, remember that it returns a redis client. So I'm going to write redis client, redis connected. So let's call these two functions, connect DB and connect redis. Let's say both DB connection, redis connection takes a second. to connect. I'm going to say sleep for a time dot second. um, same goes with the Redis. That's cool, and we'll try to see how much time it is taking to how much time our program is taking for executing. So I'm gonna write time dot now, and instead of main I'm gonna print executed in time dot since pass now, and let's run. So that should take about 2 seconds. Yeah, so it's going to take 2 seconds. The connectDB is going to return a DB client. Let me write DB client, and for the Redis I'm going to write Redis client. Come on. Okay, so we have both the Redis DB and Redis client. I'm going to print them. Let's get DB client and the Redis client. Let's run this. So that's going to take 2 seconds. We have both DB connection and Redis connect, right? So now think about this scenario. So we are running both DB connection, Redis connection sequentially. That means your main function is taking around 2 seconds. The whole program is taking 2 seconds. Even though DB client, Redis client are can be run concurrently. Since connect DB is not really dependent on DB client, that means we can run both of them concurrently. So if you could run both them concurrently, it should take about 1 second rather than 2 seconds, right? So now to achieve these things, to communicate between, so what we're going to do, I'm going to run them concurrently to the main function. So how are we going to do that? So let's say I want to write go code in front of them and go in front of them, right? So let's run. So undefined DB client, since we don't have, so we're getting undefined. So now as expected, we don't get these results, and we are running them concurrently, and your function is not waiting them for to finish. So now the first problem, what we want to do is how do we can communicate between the main go routine to connect DB and Redis go routine, and wait till connect DB and connect Redis both are done, right? So to do that, we need a channel. So channel is which helps us to communicate between the two go routines. So how do we solve this problem using channels? Let's see. So I'm going to create first channel with let's say dbchan. So the creation of channel is pretty simple, right? Make, and this is a channel type, and what type of data that you are trying to put into the channel. So the type of the channel is for this example would be string. Remember, it will be different in your case. And let's create a Redis channel. I'm gonna write make chan. This also a string. Makes sense. Now to communicate between this go routine to main go routine, we have to send this channel to this function. So let's send this channel to that function, and we have, so this function has to get the channel. So I'm gonna write channel is of type chan, which is of type string. So let's do this as well. Now, since ConnectDB and ConnectRedis runs on different Go routines to the main function, you cannot return data from that Go routine to this Go routine directly. So I'm going to remove this return thing, and we'll remove this as well. Probably I'll comment it out for now. And so say we are sending the channel, send channel here as well. So let's see how it goes. So it's executed in 0 seconds. It's still not waiting for the channel, right? The first step to do that is let's put this data into this channel and try to read that channel data into this main coroutine. So what I'm going to do now, so let's uncomment this code and put this channel. To send the data into the channel, we can write put arrow mark towards the channel. That means you are putting the data into the channel. And let's uncomment this as well. Write this thing. Cool. So let's run and see how it goes. So it's still not waiting for that thing, right? So even though we are putting the data inside the channel, we are not reading that channel data into the main. So how do we read the channel? You might have guessed already. So let's say db client um, channel to read the channel. So if the arrow going outside of that channel, like outwards to the channel, that means we are getting the data from the channel. So it's db chan and db client like redis chan um, redis channel. So we have both the data inside it we have. So let's see how it goes. It's not going to run because what we have done. Okay, so this is not the channel problem. It's client, right? So let's run. So we have declared the db client and redis client but never used. So let's use them. fmt dot println db client and redis client. So let's run. Now our function is waiting for those channels and it's taking about 1 second, right? So now what we have done is that we are running these two programs concurrently. That means even though each function is taking 1 second, since we are running these two functions concurrently, that means like it takes combinedly 1 second, right? So if it is 2 seconds, then it's going to take 2 seconds. The highest is your execution time. So I hope that was clear. So what we have done that, so we have running connect and connectivities in different Go routines. Since that it is running in different Go routine to compared to main Go routine, main Go routine will not be aware or will not wait till those Go routine finishes. So we have to find a way to communicate between Go routines. We can communicate between them via channels. So we have created a channel of type string. We have both two channels, dbchan and redischan. Then we are sending those channels to these functions, and then we are putting the data by the syntax. So remember that if any data going towards the channel, that means you are putting data inside the channel. And yeah, so it's combined, it's taking 1 second. I hope it was clear, and if you have any doubts or any clarification, let me know in comment section below. We can discuss over there. So we have seen converting a function to a Go routine. We have seen the channels, right? We did not see yet how do we use. I think we have done about the multiple channels. Let's talk about channels in loop. Okay, so this is fair. Let's say, what if you have an array of data and we want to get the data from somewhere? Um, let's write the example and probably I'll try to explain over the example. So let's say we have function. Um, we have a function that it's like, let's say, um, read data from somewhere and returns a string, and probably it's going to take a same like 10 second to read the data. From there, what we can do, let's say we have function. That function, like let's say we have users and we want to send that user to the read data function. and it will return some sort of data after a second. Okay, so let's say it takes user ID, which is of types probably an integer. I want to return fmt dot sprintf. It says hello user ID. So we have a read data function which takes about a second and returns some hello user ID, something like that. So let's say we have a function, let's say iterator. Let's say we have users of type integer, probably data is like 1, 2, 3, 4, and we will read the data for the each user. That means like we can do for value, let's put it as user, and we can range over we can range over the data like users, then call it read data and send the user, then yeah, I think so. I think this is what we want, like result. We'll get the result, and like we will have println result, the result. What happened? User parameter should be user ID. Looks fine. I'm gonna call it function iterator. Let's run this program. Undefined user ID. I think here. So what we have? Oh yeah. So I forgot to write mention return. Let's run. So first we have both the clients, then we have result one after another, and which each iteration takes about a second, and total execution time is 5. So now what we're going to do, since each iterator doesn't depend on the previous result, that means like hello 2 does not depend on hello 1, and 3 to 2, and 4 to 1, 4 to 3. We can run all the iterator in concurrently, right? So let's do that first. First, what do we need? We need a channel. So let's create a channel. I'm going to call user chan. Is going to make a channel which will probably take an integer. How do we have to run each iterator function. For each iterator we have to run the function concurrently. So how do we write? So we will put go routine go keyword in front of that function, and we will not receive data like this since you cannot directly return from that go routine, and we have to send the channel to that function. I'm going to write user chan, and user, I'm going to send user channel is some here. So we will receive a channel of type chan which will take an integer. That makes sense. Let's see and how it runs. Yep. So once we get the DB client and Redis client, it's not waiting for these things to finish, because even we are sending channel to the go routine, that function, but we are not waiting for that, right? Then let's wait for them. So it's fairly simple. So what I'm going to do is that I can write a function, iterate through them. There are multiple ways to do that. Let's take a bigger route, then we'll come back to it. Let's come back to see how can we improve that code as well. The first step is I equal to 0, I less than I equal to length of users, then I plus plus. So we will get the data, each data from that function. So what I'm going to write, like same, will follow the same thing. Result comes from this channel, and the channel is user channel. Then I'm going to print that right here. Result result. Probably I could have taken a good name. I don't know. So let's see how it goes. So all goroutines are deadlocked. Yeah. So since what happened is that we have 0, but what we're doing is that it is going to read from 0 to its length. That means um, we have data inside the channel 4. The length of the data inside the channel is 4. Since we are starting from 0 to its length, we are trying to read the 5th data also, right? So probably I'll explain in a bit. So since we are starting from 0, what I have to do is like -1. Still deadlock. What happened? So we are reading the channel data. So we have all the things. Oh yeah. So there is one more thing, right? So we are not inserting the data into the channel. So if you're not inserting data into the channel, and if you are reading, trying to read the data, and if the channel is empty, it's going to throw an error. So let's start putting the data into the channel. Channel. So will not return string directly from that function. We'll put the data inside channel, and let's see. What's the error? So we have, oh, it's not int, it has to be string. Cool. So it will say hello 4321, and it's totally executed in 2. So the reason it being executed in 2 seconds is that we are running each iterator into its own go routine, and then we are trying to read the data from those channels, which is of length users. I hope it was clear. And since we are running read data function concurrently, it's going to take about 1 second. And since we are running both the functions concurrently, which is going to take 1 second, and all the users concurrently, it's going to take 1 second, right? Okay. I know I'm not really big fan of writing. Okay, I forgot before I forget anything. So once you're done with the channel, it's always good practice to close the channel, read channel. Once we read we can actually close channel like Redis channel. I'm not really sure that I can db channel. Let's see how it goes. So channel, non-channel invalid operator, not client, come on, db channel. Okay, so it's going to take only 2 seconds since we are running all the things concurrently. Instead of taking 7 seconds, it's going to take 2 seconds. I think it's pretty powerful, right? Okay, so I think we have done with the loop as well. Okay, I forgot, right? So I'm not really big fan of writing for loops like this. So there is way to improve this code. It's fine as it is. I'm not saying it's not good, but I'm not a big fan of it. So I'm gonna comment this out code. What I'm gonna do, I'm gonna range over it. I'm gonna create a array of length users of type an integer. This will not run because constant arrow bound, so we cannot create the length of the channel because the channel of the user can change if you are using. So there is a one package which helps you to do that. So if you know the length of the channel before, what I can do, the channel length is 4, and I'm gonna put this code right here. It's going to run 4 times and it's going to give the value, right? But the problem with this code that you might not know the length um, at that time, and I cannot pass the length of the array at dynamically. So if you know that length is going to be static, you can use this as well. You might be wondering why I'm not using range over the user, right? So let's do that as well. For I'm gonna retread like so I'm not going to use any of those things. So it's perfectly fine to write range over the users. Let's see how it goes. Right, so we have 2 for 1. I can range over the users and get the data, all the data, but you have to make sure that this length is not going to change dynamically, so make sure of that and you're good to go. So you can do either this or that, it's up to you. I'm not really a big fan of writing this, so I'm going to remove this thing. Okay, let's run this code and see how it goes. Okay, all right. Let's. The one interesting thing, even if you see that, right, even though we are iterating through one by one in order like 1 2 3 4 5 1 2 1 2 3 4, the result will not be in the same line because they are running concurrently. There might be like a split second difference, so you cannot have that. Okay, I think we are done there. We have seen loop over the channels. What if I have like 2 loops running somewhere? Then let's create the scenario and write the program. Then I can probably explain a little bit. So I'm going to create a function. Come on, function. What do you want to name? Let's name select. Select example, I guess. I'm not really good with names, so I'm gonna call that function select example. Here, let's say let's imagine you have 2 different kinds of data. Let's say func read items, and so the read items will take some time. So I'm gonna like sleep for a minute. Second, I want to sleep for a second, and I would like to have a channel. So we're not going to return first, so we know how to do that. So we are directly going ahead with the channel. So this will return a channel of the channel. Probably I'm going to return the channel is going to take string. You can actually write. You can actually have channel, which is going to we just want to write to the channel, but not read to the channel. You can restrict that as well. So this particular channel is going to only you can write to the channel, but you cannot read from the channel. I hope that syntax is right. I think it's yes, that's just syntax is right. I'm not really good with syntax, so read items. This function is going to take a second. Once second is done, this channel will have the data. So I'm gonna like printf item, and then items printf. So it okay, this item is going to take a string, which is will come in the item. Let's take the item ID. So I think it's better to have an ID rather than having a string. like push that item ID into that. So it reads the items. Then func read items. We have items. What we can have? Let's say read tokens. This will also take a channel. Channel. This will also, we can write to the channel, but we cannot read. We cannot read the channel. So then I token ID integer. So I'm gonna copy the whole stuff and paste it here. So we can have channel and the token ID right here. So what we have, like we have two functions, read items and read token, and each is going to take a second. Then we'll have like items and the tokens into the array. Then we will wait for them, and let's see how it goes. Like we'll write an example. I'll try to explain it as well. So let's say we have items of an type array of integer. Yes, I'll have 1 comma 2 comma 3 comma 4. That's items, and we'll have tokens. We have token of integer, probably like 5 comma 6 comma 7 8. Then we'll have some sort of like iterator. Like I'm gonna have iterator which will send the data. Will spawn that go routine. So first we will have item, range over it, read items. So before that we need channels. I'm gonna write items chan, make chan, which will take data of string. We'll also have tokens chan, and we'll take the data as well. Inside this this iterator, I'm gonna spawn that go routine of read items. I have to send the items channel, and second one is the item. Okay. Looks good. But if you see, I have to send the type of the channel which can only pushes the data, right? So what's the syntax? Let's try to guess. Otherwise, if I fail to remember the syntax, let's read the syntax. Since data comes towards the channel, you can push the data into the channel. That means I'll have something like I hope so. Syntax is expected comma. It's not. Is it so? I'm not really sure. It's not the same. Let's see. Insert channel type. Insert channel type. Channels by example. I should have remembered, but I'm not really good with syntax. So go function which reads the data. So that's not the same thing that we want to read. Not really sure. So it reads the data. Okay. Insert only channel go like. Send and receive by blocking default. uh, yes, this is what we want. So this is a syntax which we have created, so we can insert the data. Oh, the origin should be it. So this syntax is perfectly fine. That means we can insert the data. So that means, so when you're trying to read, so you can do something like this. Let's, I hope it's fine, because we'll still have, we're inserting the data. Tokens undeclared but never used. That means like we are good to go. So since we are iterating through that, what I'm going to do, like for I'm going to write for the tokens. Before we go for the tokens, I would like to read the tokens. Then we do that. Like, let's say for, we can spawn the tokens as well right now. Let's spawn the token. Token equal to range tokens. Um, eight items. Like tokens chan, which sends the token. Then we know how to wait for the things, like for range items. Then like I can write fmt dot println, read the data from the channel, that since we are reading like items chan, I'm going to do the same thing for tokens, from the token chan, probably like token would make more sense, I guess. Item, are we good? I think we're good. Let's see. So once you're done, close the channel like items chan, and then close tokens chan. Let's run. Syntax error before the comma. Yeah, forgot the comma. Single operators and only. Should be fine. So we are sending the channel, reading the data from the channel. This will, I see. No, we can't do that. So because this channel is only for the inserting the data, so we will remove that from here. Let's run this code. Missing channel type. Come on, what is the channel type? String. So it's connected and it's done. It's take 3 seconds. Okay. So we are running all of them concurrently. Since it's done, it's going to wait. We are reading all the channels and everything is done, right? So there is one more thing that we can discuss. Instead of writing 2 for ranges for those channels, what we can do, we can read channels, 2 or more channels at a time, using select. So I'm going to rewrite this code a little bit. Before we run that code, let's see what happens if we try to read the channel from here. So let me go back to here 1 second. I think it's good to go. So what happens if I try to read the data from the channel? So after putting the data, of course, that should not compile because receive from send only channel, right? So that means like this channel, you can insert the data into that channel. You can only insert, you cannot read the data. Okay. So instead of two for loops, what we can do, we can use select, which will read two channels at a time, and we can take advantage of that as well. So let's rewrite this in different way. So we have items and the tokens. What we can do, like for I equal to 0, I less than or equal to length of items plus length of tokens, then I plus plus. We can write select. Now select can read multiple channels at a time. I'm like item. So start with case, obviously. So the case would be item. So we'll read the item here, which will be equivalent to data receiving from the item channel, items channel, and then that would read fmt dot println item. Item. Let's format this real quick. Okay, so we have these things. Let's run this code and see how it runs first. So we have those things, we have read. Yes. The reason being is that we have lots of length, but we are reading from only single channel. So let's read that from the token as well. Say this we define as token. I'm going to write token here, tokens channel. So it starts from 0, less than or equal to 1. We still have deadlock. The reason being, as always, I forgot -1. I hate for loops. Yes. So now you can see we are waiting for the multiple channels using select. So what happens is that we will iterate through combined length of items and tokens. Um, then what we'll do is that so the selective is going to iterate through the combined length, and whenever that any specific channel returns the data, it is going to map to that case and will print the data. So if you are not really comfortable, you can still have multiple for loops to read the data, but I think this is much more cleaner to even to see and to write, right? Okay, I think we are done with select as well. Let's put it to done. I would like to discuss about break group. Let's discuss about the weight group. So to discuss about the weight group, what I'm going to do, there might be scenario where let's say where is the first function, say hello, right? So let's say the scenario, I want to say hello, which is going to take a second. Let's say not say hello. I think say hello is not a real-time example would be, I guess. But still, let's see. So I'm going to say hello, which is going to take a second. After a second, it's going to say hello. Let's say I'm going to say a name. I'm going to write a string instead of just saying println. Probably it will say to hello to someone, like fmt. Let's write the fmt dot sprintf. I'm like hello, like name, like the name where we have name. We have like, I'm going to call this say hello, and it's going to say hello. Um, Really quick, uh, I'm gonna right. Okay, so till now we have seen spawning the Go routines and running them concurrently, and we want that result from that function, right? So what if you don't want result from that function? You just want to run and let it go. You don't care about the result, whatever it says, right? So let's say I want to say hello. I don't care. I don't want any data from that function, but it's going to take a second, and we'll have like a number of users. So let's say func hello, like hello says, okay, like, oh man, print hello. I'm not really sure. So let's say I have students. um, I'm gonna have a string names like hmm, like go node rust. um, I'm gonna range over them, for name, not name, student. Come on, man. Student. Man, for some days I'm gonna kill myself. Student. um, Range over students. I'm gonna call this say hello and send the student name. Okay, I'm gonna call this function right from right here, print hello. This is going to take a lot of time. So we have seen we were running all the things in Go routine concurrently, and we have seen it takes about 3 seconds, and previously it has taken about 3 seconds. Now we have 3 users, and we are calling them uh, sequentially without running concurrently. So this is going to take 6 seconds. Now, the first step, I'm going to I'm going to run say hello concurrently, because I'm not going to, I don't have to wait for, node doesn't have to wait for go to finish, and the rest doesn't have to wait for node to finish, right? The first step, I'm going to write go, so it runs concurrently. Probably by this time you know that it's not going to print, because it might or might not print actually. So it prints hello. I'm gonna clear this. So go run, let go. Says hello, hello, hello. So it's about to take a second. What if it's not going to wait for a second? I'm gonna say hello and go routine. I want to wait till all the go routines to finish. I'm gonna print like fmt dot print hello is done. You can see it prints hello is done first, and then it prints all these things, right? That means our code is not working as they expected, right? So what I want is that I want to run say hello concurrently, then wait for all the go routines to finish, and then I will say hello is done, right? So to do that, the first thing is that I don't care about I don't need any data from that say hello, but I want to wait till I am done saying hello to all the students. Okay, so to do that, we can make use of wait group. So wait group will wait for all the go routines to finish for the given number. So what I mean by this is that, so let's say I have weight group. All right, sync dot weight group. So I have to send the weight group to the specific go routine. Before I send to that specific go routine, I'm gonna add this specific go routine to my weight group, so that when it says done, it's going to reduce the counter. So let's see, let's write some code and try to explain. So I'm adding one um, so I'm adding one go routine, like so this will take like uh, adds adds the delta which may be negative to weight group counter. So I'm adding the counter to the weight group, and I'll send the weight group to this go routine. So I'm gonna read this go routine from here. So go routine and star sync dot weight. So once I'm done, I'm gonna say it's done. Come on. Once it's done, I'm gonna say done, and I will wait for all the go routines to finish. Now, so what we have done here, so we have created weight group, and for each iterator we are adding a counter. So it is going to be cumulative, like the weight group counter is about length of students, and this done will wait for all the go routines to be, uh, not done, come on, wait. So this weight group will wait uh, until its counter becomes 0. So when it will counter will become 0 once all the go routine says I'm done, right? So let's run. Now you can see earlier we have seen hello done is printing before all the hello is done, right? So weight group is really powerful when you spawn a lot of go routines, but you don't care about the data from that go routine. Again, but you want to wait till those go routines finish, right? Okay, I hope that makes sense. So we are done about weight groups as well. So, mhm. So I'm going to write one last example. And I'm pretty sure that I'm going to write worst possible variable names, worst possible function names. Please bear with me. So last example, I would like to discuss about the mutex. So first, we'll write an example. We'll create the problem and we'll try to solve that thing with the mutex. The first step, like let's say func um, func. Hmm, come on, man. When you are going to write good examples? Let's say I'm going to write update age, then I'll get the users. So update age function receives users. um, Update it receives the users. Then what it does, mm, so let's say hmm, oh man, this is so tough. So what sort of example would be better? Mm-hmm. Okay, I'm going to take a random example. So yeah, so I'm going to take a users which is of type string, array of strings. I'm going to also receive the name of type string. um, so we have users and name. What I'm going to do, like I'm going to append that to append um, and get username from any of those functions, like read items, probably func read name. which returns a string which takes about a second to finish. Time dot sleep, time dot second. After that is going to return fmt dot sprint f and say hello, hello name. So this will receive a name, string I guess, and let's write name. So what we have, like we have read name, we have a pen, then what I'm going to do, I'm going to read this name, read name, send the name, wait for the result, then append that to user. So I think makes sense. Func users. Okay, I'm going to write mutex example. First we have users. Let's say we have users. Let's say, what are the users we have? A and B and C. So first step, I would like to iterate through the users and get the updated name. So we have users, and we will have updated users, which is of len string. So then what we have, like for k value, let's write user, not the value. I'm going to range over the users, like update, then I'm going to say update age. For the update age, it requires update users and the user itself. Then once we are done, I want to print users, comma, probably like updated users, which will be updated users. Let's run and have it, see how it goes. First, like mutex example. What happened? So read data, what we, oh come on, read name now, I don't mean that. Right. So it's gonna wait a lot of time. So it says like so we have updated users as an empty. Why is that? Oh idiot, you have to send the pointer so that it gets updated. So like new, right, string array. So it takes the pointer, so that means it receives the user pointer. So that means like users, I'm gonna use the pointer. That means it is going to update. I should see the user's data. Yes. Since we have updated, like let's use the pointers to get the data, not just the address of it. Like now you can see we have hello name A, hello name B, hello name C. But if you see that, right, it takes about 6 seconds. Now we have, since we are using the pointer, since we are sending the data to right here, we can run them concurrently, right? So once we run them concurrently, let's see how it runs first. I can see empty data because since it runs concurrently, this will run and this will go to exactly like there. So even before it mutates the data, we are reading the data which is still empty, right? So to avoid this thing, so what we have learned earlier, so if we have like print array, we made use of wait group, and then we have attached edge, add, then we have waited for them, right? So I'm gonna do exactly that. So before I'm going to print these things, I'm going to wait for all the users mutation to be finished. So to do that, I want to create a wait group. We have seen that wait group. Remember that the wait group has to the same wait group. So you should have the same wait group which is waiting for all the go routines to finish. So basically like a user's go routine. So I'm going to send the wait group as well. Here I have to read the wait group star, not star, like stay star and sync not wait group. Once I append the data, I can use differ. So since we don't have a chance of error, I can write differ wgs dot done. We have to attach here, add one, and wait for all them to finish. Let's see how it behaves. Um, we we have received some sort of data, but the problem with this thing that we don't have the full array. So if you see, we have sent a comma b comma c, but we have only b comma c. Why? So let's print one more time. Now we have only a comma c, right? So this is before we go there. Let's see what um, users we are being received, right? So let's say fmt.print comma fmt.println users, what type of users we are trying to receive, right? So that should print users empty empty empty, but we are printing before append, so it's always empty, of course. Okay, now I think it's pretty clear. So first we had C, and then the second go routine had C, so that it is attached to B. Then we have a comma C comma B comma A. But if we run one more time, that result is going to change, right? So now we can see the result is A comma B. Reason being, the first go routine has received A comma B. So when we tried to mutate the data, we had A comma B. Then we had A. That means like the okay. Let me put the charger. Okay. As you can see, the first go routine has received A comma B. The second go routine has received B. The third go routine has received C. So the result is it's pretty random, right? So the reason being is that, so we have we spawn the go routines, and we have sent the a pointer of the user update users, and we are mutating the pointers in each go routine. So what happens in that case is that each go routines concurrently is trying to append the data, so mutate the data. So whatever the last go routine has users, it will be the last data, right? So we don't have like there is no guarantee that we is going to get the known result, right? But if you see, the program is still taking 4 seconds, which is a good thing, but we don't have correct data with us. So previously, before running with go routines, it used to run like 6 seconds. Now it runs in 4 seconds, which is good thing, but we don't have the correct data. So to avoid these things, before we mutate the data, I would like to log this user, mutate the data, and unlock the user, right? So if you have written this code in Rust, it's not going to compile. because when you share any resource between threads or the go routines, you have to lock the resource before you mutating the resource. If you're not locking the resource, your results may vary, right? So let's write the mutex and see how it goes. So I'm going to write mutex sing dot mutex. I have to send the mutex, and here we're going to write receive the mutex sing dot mutex. So before I mutate the data, I'm gonna mutex log the resource. Once I'm done with that, I'm gonna unlock the resource. What it means that before we are appending the data, all the go routines will wait until I unlock it, right? So once I lock it, all the go routines will wait unless unlock it. That means we are, even though we are running update age concurrently, but we are still mutating the user's pointer concurrently, sequentially. So let's see, locks the m. If the locks is already in use, the calling go routine blocks until the mutex is available. Okay, that's it, and let's see how it runs. Now we can see hello a comma b comma c, right? So I'm gonna remove this fmt right here. Let's run multiple times so we absolutely sure that it's going to give you the result that you need. We have seen a b and c. Let's run one more time just to make sure that we are getting all the data that we need. Now we are getting all the data every time we run the program. That's what we wanted, right? So what we have seen here, we are have bunch of users. We don't want data from that function, so that we are sending the array, so that we will we'll append the array. I think we have covered things that I wanted to cover. I hope it was clear, and I don't have a good audio gear to record these videos. Once this lockdown is done, probably I'll get a good audio gear, and since it's lockdown pretty much everywhere, I just wanted to make some videos and I wanted to share the things that I have learned. I really hope that this was useful, and please let me know your feedback, good or bad, in the comment section below. And if you have any doubts, if you need any clarification, let me know. I'll be happy to help. Until then, I'll see you in the next video. Thanks.